Greetings, students. Today we're going to go over the Quiz 2 practice. So let's begin. So our first question. A cattle train left Seoul, traveling towards New York at an average speed of 45. So our average speed for the first train is 45. Sometime later, so we don't know what time later, a second train left in the same direction with an average speed of 65. So 20 miles per hour faster. After traveling for 9 hours, the second train, the diesel train, caught up to the cattle train. And it's asking me how long did the cattle train travel. So we're going to use distance equals rate times time here to figure out what the distance was that the second train traveled, which will be the same distance as the first train. So my distance is equal to my rate of 65 times my time of 9 hours. My distance is 585 miles. Now the question is asking, how long did the cattle train travel? So it is ambiguous somewhat. I would ask, if you asked me on the test whether I wanted the time in terms of the length or the distance in terms of length, I would tell you. We actually want the time, the amount of hours it traveled, rather than the length it traveled. So if we take 585 and we divide it by 45 miles an hour, we're going to get 13 hours. Now again, when you're working this on the test, we're not going to require you to do this division by hand. So keep that in mind and grab a calculator when you're trying to do these practice tests, please, so you don't have algebra mistakes or silly mistakes. We have a question 2 here, which is using the same formula, d equals r times t, or distance equals rate times time. So let's look at this one. Totsikin left the lighthouse and traveled east. Toxican, sorry. This is a funny name. Mark left 1 hour later, traveling at 80 kilometers an hour. So there's our rate, 80 kilometers an hour, in an effort to catch up to him, the Totsikan. After traveling for 3 hours, Mark finally caught up. So again, we're going to take our distance equals rate times time. Rate times time. My distance is 240 kilometers this time. Now again, this one says find Tokskin's average speed. So we don't want 240 kilometers, we want his average speed. So our 240 kilometers is how far Tokskin traveled. And we're going to divide that by, not by 3, but by 4. Now we're using 4 here for the time. So distance equals rate times time. Because Mark left an hour later. He didn't leave at the same time as Totskin. Because if they'd left at the same time, well, they'd be starting at the same spot, so it wouldn't be a valid question. Anyways, dividing 4 to 240 here. Our rate is 60. The units are important. It's kilometers per hour. Make sure you pay attention to the units here. This is kilometers per hour rather than miles per hour, because it was kilometers that he traveled. All right, question 3. Still going to do distance equals rate times time. All right, so here we got a jet. It made a trip to an air show. It took it 10 hours. The trip there took 10 hours. The trip back took 9 hours. So the trip back was an hour shorter. What is the jet's average speed on the trip there if it averaged 500 kilometers on the return trip? So we have our speed, 500 kilometers, and our time. So D is equal to 500 kilometers an hour times by 9 hours. So it traveled 4,500 kilometers. The jet did. Now this was how far it traveled. Again, we want the speed on the trip there. So we're going to take 4,500 kilometers, our new distance, equals, we don't know our rate because we're looking for our rate, we're looking how fast it traveled, times by, well, it took it 10 hours to get there on the trip there. So now we divide 10 into 4,500. We get a rate of 450. Again, units are important. It's kilometers per hour. All right, so on those two we were solving for, rate. On this one, we were solving for time. Now on the quiz, again, I might ask you for maybe distance on one of these questions. Or instead of asking you for 2 rates in one time, I might ask you for distance on one of them. And you'd have d equals r times t, distance equals rate times time for these questions. All right, moving on to the next concept, solving equations. These, if we did really well with in class, you've been doing these quite a lot in your other classes as well, Algebra 1, Algebra 2, Geometry. So we'll go over these, but I'm not expecting much difficulty. Distribute, in other words, eliminate parentheses first. Always eliminate parentheses first. And you can do that with division as well on some questions. So if you see a shortcut by doing division first, you can take it. I don't mind as long as your answer is the same and as long as you have work for the question. All right, so the 8m's here will cancel or reduce because positive 8m minus negative 8m. And then we'll have 14 plus 96, adding the 14 over to the 96 to get 110 equals negative 22m. And then we'll divide by negative 20 to get negative 5. It's very easy to check your work on these. You can plug the answer in and see if it works. So it's actually easy to get the answer by plugging it in and seeing if it works. That's why I want you to show your work too, so that you can verify that you actually did the question. All right, next question, question 5. We have 11n plus 45n minus 45 equals 77 plus 56n. All right, so now we're going to take these two and add them together, and that's going to yield 56n minus 45 equals 77 plus 56n. Notice that it's the same on both sides of the variable here. So when I subtract from the left to the right, or from the right to the left, either way, they're going to cancel each other out because it's the same 56n. And we're left with a statement only, that negative 45 is equal to 77, which is a false statement. It's not a valid statement. A slash to the equal sign. That's an invalid statement, meaning this has no solutions because there is no value of n that will make negative 45 equal to 77 on this question. All right, so that's the front 5 questions. All right, next questions, questions 6 through 11. So the next 6 questions. Here we're going to distribute. Always distribute, eliminate parentheses. So we have 11b minus 55 equals 4b plus 8. Take the 4b to the 11b, of course, to get 7b minus 55 equals 8. Take the 55 to the 8 to get 7b is equal to 63, and divide by 7 to get 9. And again, you can check your work very easily. Substitute the 9n for b, and you would have 4 times 11, which is 44. And then you'd have 4 times 11 there as well, which is also 44. All right, so with this one, question 7, when you have denominators, it's important for you to understand that you either eliminate the denominators by timesing through by them or get everything with the same denominator. So if a letter's in the denominator, it's often easier to just get them all to have that same letter in the denominator. So I'm going to times this one by k plus 1, top and bottom, which is going to make this a 2k plus 2. So I'm going to have k minus 3 now, and then minus the other 3. So this k minus 3 is here. This other minus 3 is here. That's going to equal to the distributed value of this 2 to the k plus 1, 2k plus 2. Again, what I did there, I times by k plus 1 over k plus 1 to make this so it has the same denominator. That way it's going to be equal. Or you can think of it as I times by the k plus 1 on the left and the right. So therefore it'll cancel out the k plus 1 on the left and it'll move it to the right. If you wanted to think of it that way, that's also another way to think of it. Anyways, k minus 6 is equal to 2k plus 2. Taking 2k from k is going to yield negative k minus 6 equals 2. Adding 6 to 2 is going to yield 8. And I want negative 8 here. It's important you check for extraneous solutions, so put the negative 8 in, see if it actually works. Because sometimes these solutions won't work. Now, obviously, this is multiple choice, so it's not going to have an extraneous solution because it doesn't have the option here of no solution. But it's important you check for extraneous solutions with these questions and verify that it's not extraneous in the homeworks. and on the questions that have the option of extraneous solution. So if I put negative 8 in for k, this would be negative 11 divided by negative 7 minus 3 divided by negative 7 equals 2. And that is true because negative 11 minus 3 is negative 14 divided by 7, which is 2. All right. Similar concept here. I'm going to eliminate the 7p either by timesing through by it to move it to the 1 or by timesing the 1 by 7p over 7p. So 1 is equal to 7p minus 6. Again, I move that 7p from the bottom to the top by timesing by it or by timesing top and bottom by 7p. Adding 6 to 1, we get 7. Dividing 7 into 7, we get p is equal to 1. And again, we're going to check 1/7 is equal to 1 minus 6/7. That is a true statement. All right, here we got the k in the bottom for all of these. We just don't have the 3 in the bottom on these two. So again, what we're going to do is we're going to move that 3 to the bottom on these two fractions by timesing by it, or by distributing it, if you want to call it that way. So we're going to times by 3 here on the right-hand side, or we're going to times the whole thing by 3, if you want to think of it that way. You can think of it either way. So here I was timesing the whole thing by 7p to get rid of the bottom. Here I was timesing the whole thing by k plus 1 to get rid of the bottom. Or here you can think of it, I'm timesing the whole thing by 3k to get rid of the bottom. So this is going to make the k's gone, the 3's gone here. The 3 is going to distribute to the 1 and also to the k plus 1. So that's going to become a 3 times 1. And this is going to become a 3k plus 3. 3k plus 3, like so. All right, combining the 3's together, we're going to get 6. 1 is equal to 3k plus 6. Taking 6 from 1, we're going to get negative 5 equals 3k, and then dividing 3 into negative 5, we get negative 5/3. Now, with the fractional values, you don't really have to check to see if it's extraneous, because with the fractional values, you're not going to have extraneous values that are fractional in this class like that, as far as what I've seen in the work, or on the quiz this week at least. So don't worry about the fractional value, you're checking it. Only worry about the integer values. Anyways, so general concept solving equations, make the bottoms the same, or times through by the denominators. Make the denominator the same, or times through by it. All right, questions 10 and 11. We're going to do a table of values. It says make a table of 5 values. So x and y input output tables. So good strategy is to use 0, -1, -2, +1, +2. You don't have to use those values, but those are good values to use. They will always work, or not always work, but they'll be decent values to use. So starting off with 0, building our way out from 0. Again, you can use a calculator, assist you here. 3 times -2, absolute value -2, so 3 times 2 is 6 plus 1 is 7. So 0 and 7 would be my first value there. Then my value for 1. Well, when I put in 1, this becomes 2 minus 2, which is nothing. 3 times nothing plus, well, the 1 yields 1. When I put in 2, this becomes 4 minus 2, which is 2. So that's going to be 6 plus 1. So 2 yields the same value as 0 did, because it's absolute value. So that tells me right there where my vertex is for my absolute value equation. If you remember what that's called, it's called a vertex. So that tells me actually what the equation does. It goes here and here. And then as far as the other two values here, we'll do the other two values right now. This is going to be 3 times 4 plus 1, so it's going to be 13. And this is going to, 2 times 2 is 4, minus another 2 is 6. 3 times 6 plus 1, 18 plus 1 is 19. So there's my 5 values on my table. Sorry you couldn't see it as I was doing it. I'm rusty with this, haven't done it all summer long. But we put the values of x in, we put 5 values of x in, found the values of y. That's what we did there. And we're going to do the same thing for question 11. Put the values in for x, find the values of y. And so again, this is kind of, it can be kind of lengthy because some of these are kind of long, larger values. But start with a 0. 0 minus 0 plus 3, 0 and 3. 0 and 3. And then we can do 1. So 1 would be 1 minus 2 plus 3. 1 minus 2 plus 3 would be the value of 1. So negative 1 plus 3 is 2. Or you could think of it as negative 1 plus 3, 2. So 1 yields 2. Then we're going to do 2. So 2 cubed is 8. 2 times 4 is also 8. So 8 minus 8 plus 3. So there's 3 again. So 2 comma 3. Then we're going to do negative 1. So negative 1 cubed is negative 1. Negative 2 times 1 is negative 2. So negative 1 minus 2 plus 3. Well, that's 0. Negative 1 is 0. And then we're going to do negative 2. So that's going to yield negative 8. 2 squared again is 4, so that's going to yield negative 8 minus 8 plus 3. So negative 16 plus 3, which is negative 13. So there we have it, our values. So again, a cubic function is going to be it's going to have the, what's it called, the relative min and maximum. So it's going to have the curvature to it, or the snake to it. So if your curvature is not quite right, that's fine. You just have to have the values plotted right, and then the graph going in the general right direction is all you have to have. So it makes it kind of a snake shape. All right, next question, question 12. So we're going to have here a table, x and y, negative 2, negative 1, 0, 1, and 2. So putting in 0 is going to yield a decimal value. So I can put in 0 using the calculator here. The square root of 2 minus 5. Oops, sorry. I have to use a parenthesis. Square root of 2 minus 5. Negative 3.6. Then I can put in 1. The square root of 3 minus 5 is negative 3.2, or 3.3 when it rounds. Then we have the square root of 4 minus 5. Now that one we can do we don't have to use calculator 4 because square root of 4 is 2. That's negative 3. So that's the first one I'm going to actually plot, 2, negative 3. And the reason that's the first one I'm going to plot is because it's the easiest 1-2 plot of that group, and it's the only one that's actually an integer value. I can plot the other ones as well if I want. They're just, here and here, those 2 spots. All right, next one. Negative 1 goes in. So the square root, when that's negative 1, it's going to be square root of 1 minus 5. Square root of 1 minus 5 is going to be negative 4. So negative 1, negative 4. And then negative 2 goes in, which is going to make that the square root of 0 minus 5, negative 5. Once I get these values, again, I can do my graph. Now, again, this is a square root function, so it doesn't go to the left of negative 2. Nothing to the left of negative 2 is going to plot here, because that's when this square root is equal to 0. And we don't have the negative square roots, the complex roots, when we do a real number graph, as you've talked about last year, recall from last year. Anyway, so there's our graph. So it does curve upwards. Again, if the curvature is wrong, it's not that big of a deal. The next one here that would square it perfectly would be 9. So it should be 5 and 3. Sorry, 5 and negative 2. What am I talking about? 7. Because 7 plus 2 is 9. 7 and negative 2. But if your curvature is not quite right, that's fine. It doesn't have to be perfect. All right, 13 is kind of a little bit of a tricky question to understand what I'm asking for. It says write the equation in standard form. That's actually the instruction for number 14. So here's what a standard form equation of a circle looks like. So we're going to have here on number 14, I'll come back to 13 in a second, x plus 1 quantity squared plus y minus 13 quantity squared is equal to 4, because 2 squared is 4. So our standard form for equation of circles, x minus h squared plus y minus k squared equals r squared. Right, so this one here is asking what the center and the radius is. So I forgot to add in the instructions here on this one. So I will put them on the test as well, and I'll remind you on the test coming up on Friday for this that I want the center and the radius is what I want here. So the center here is -5, +5. Again, it's opposite of h, opposite of k. And the radius is going to be square root of 100, which is 10. That's what I'm asking for there. All right, question 15. Identify the center and radius, then sketch the graph. So here I'm asking you the same as 13, but then also graph it. So the center here is -1, 3. Opposite of h, opposite of k. Opposites, again, just like vertex form for parabolas. -1, +3. There's my center. Radius is equal to the square root of 16, which is 4. So we're going to go up 4, left 4, down 4, and right 4. Connect the dots, and we have our circle. All right, and then the last one, number 16 here. Check for symmetry with respect to the x-axis, the y-axis, and the origin. So with this, we're going to do like we did in the notes. We can also graph it as well if we wanted to graph it. You can check for symmetry by doing a graph of the equation, if you remember how to graph that sideways parabola and folding it. So for y-axis symmetry, we plug in -x, and we see if it's the same. For x-axis symmetry, plug in -y, and see if it's the same. And for origin symmetry, we plug in -x and -y. So let's start off with x-axis symmetry, since that's what it has here first. We're going to plug in -y, and we're going to see if it's the same equation. So if x is -y, we put in -y squared plus 1, and that is the same equation, because when -y squared is squared, it becomes positive y squared. This does have x-axis symmetry. In other words, it folds sideways. It can be folded sideways. All right, next one, y-axis symmetry, plug in -x. Well, if I put in -x, it's going to equal y squared plus 1. Well, that's a different equation because x is now negative. The x didn't become positive. It didn't square out the negative, so that's not the same equation. And the same applies with origin symmetry here. If I put in -x and -y, the -y will square out and become a positive, but the x will stay as negative. So that does not have origin symmetry. And if we look at the graph of this, again, it's a sideways parabola, x equals y squared plus 1. When y is 0, x is 1. That's the x-intercept. And then as y increases in value, as y is 1, x would be 2. This is a sideways facing parabola. Same if y was -1, x would be 2. That's why this has x-axis symmetry, because it folds this way. If y was 2 or -2, x would be 5. 1, 2, 3, 4, 5. So you see it folds this way. It folds from top to bottom. And if it was the other way around, if it was y is equal to x squared plus 1, then all it would happen is it would be this way. And now it would have, instead of x-axis symmetry, it'd have y-axis symmetry for the parabola. Anyways, hopefully this helps. Come in and see me if you need help.